For decades we thought we had the scale of the cosmos figured out. The observable universe, everything we can detect, spans an astonishing 93 billion light years. That's already so incomprehensibly vast that it's almost useless to compare to anything in human experience. You could line up a stack of Milky Ways, our home galaxy, end to end, and need more than 2 million of them just to cross that space. And yet, new analysis of data from the James Webb Space Telescope is telling us something almost absurd. This might be just the teeniest fraction of reality. Recent work combining Webb's early galaxy surveys with decades of cosmic background measurements suggests the true universe could be at least 250 times larger in volume than the one we can see. In practical terms, that has a diameter of more than 23 trillion light years, and that's just the minimum. If confirmed, it means that every galaxy we've ever mapped, every star we've studied, every exoplanet we've dreamed about, all of it is just a drop in an ocean without shores. The edge we thought we knew. The observable universe is not the whole universe. It's just the region from which light has had time to reach us since the Big Bang, roughly 13.8 billion years ago, because space itself has been expanding the entire time. The most distant objects we can detect today are now about 46 billion light-years away in every direction. That's the radius of our cosmic bubble, the bubble of what's possible to see. It's tempting to imagine that beyond that edge, there's just nothing. But physics says otherwise. The universe doesn't just stop at the boundary of what's visible. That's simply the limit of our vision, like standing in the middle of a foggy field with a flashlight. The trees beyond the light beam are still there. You just can't see them. For years, cosmologists assumed the real universe could be vastly larger than our observable slice, maybe even infinite. But infinite is a slippery word in science now. With the unprecedented detail from JWST steep surveys combined with high-precision cosmic microwave background data, scientists can actually put numbers on that vastly larger. And those numbers are jaw-dropping. The 250 revelation. The idea that the universe could be hundreds of times larger in volume than the observable part. ISN knew. It builds on decades of work measuring the cosmic microwave background, CMB, the faint afterglow of the Big Bang. If the universe were small or had a wrapped topology, like a video game map that loops around, patterns in the CMB would repeat. But high-resolution maps from ESA's Planck missions show no such repetition, even at the finest scales we can measure. That lack of repetition sets a hard lower bound. The universe must be at least 250 times larger in volume than the part we can see. In linear size, that SA diameter of over 23 trillion light-years. And remember, that's just the minimum. It could be millions of times larger. But here's where JWST comes in. Webb's deep field surveys are revealing unexpected abundant, mature galaxies in the early Saint epochs of cosmic history. Galaxies so numerous and so massive that they make far more sense if the universe beyond our horizon is similarly packed. In other words, what we see in here is probably just a statistically typical patch of something unimagina, bigge. A real-world example, the giant GRB wall. Even inside our tiny visible slice, we've stumbled upon structures that challenge the limits of theory. One of the most extreme is the giant GRB well, a massive arrangement of gamma ray burst sources spanning about 1.3 billion light-years, discovered in 2020 in data from the Swift satellite. It's so vast that some cosmologists question whether it violates the cosmological principle, the idea that on large enough scales, the universe should be uniform. According to current theory, such megastructures should be incredibly rare. Yet here it is, sitting comfortably inside our observable patch. If something this large exists here, what might be lurking in the other 249 regions we never see? The cosmic architecture beyond our horizon could dwarf even the most extravagant structures we've cataloged. Another clue: the Hercules Corona Borealis Great Wall and the GRB Wall ISN Taloni. Back in 2013, astronomers identified the Hercules Corona Borealis Great Wall, a galaxy filament stretching 10 billion light years end to end, more than 1/10 the radius of the observable universe. That's on almost unthinkable scale for a coherent structure. Each of these discoveries was made within our tiny bubble of visibility. If the universe really is 250 times larger in volume, then statistically, such structures, and perhaps even larger ones, should be scattered everywhere beyond our sight. Why Webb's data matters. Before JWST, the Hubble Space Telescope gave us the deepest look into the cosmos with its ultra-deep field, a single speck of sky containing about 1,000 galaxies. Webb SCOS Webb program is doing something similar on a grander scale, mapping hundreds of thousands of galaxies across a region 3 times the area of the full moon in the sky. And what Webb is finding is shaking the foundation of our models. Bright, mature galaxies appearing just 300 million years after the Big Bang. Heavy elements like carbon and nitrogen present far earlier than expected. Structures like fully formed spiral arms billions of years too soon. These anomalies suggest galaxy Formation was not just faster, but far more widespread in the early universe, Finding that makes much more sense if we accept that our visible patch is a tiny sample of an overwhelmingly larger whole, the philosophical earthquake. If the universe is really 250 times larger in volume, our cosmic address becomes even more humbling. Every galaxy we've ever mapped, including the Milky Way, with its hundreds of billions of stars, is part of a neighborhood so small, it barely registers on the true map of the cosmos. It's like realizing that the entire ocean you thought you'd explored is actually just a tide pool on the edge of an unimaginably vast sea. And here's the kicker. We will never directly see those far-off regions. The light from them hasn't had time to reach us. And cosmic expansion means it may never will, yet. Webb's findings force us to accept they out there, shaping the true structure of reality. The search ahead. For scientists, this ISN discouraging. It's sextila rating. It means every time we think we beat close the last chapter of the cosmic story, the universe hands us a new opening paragraph. Future missions like Nancy Grace Roman Space Telescope and Euclid will map even larger volumes of the sky, probing the geometry and distribution of matter on unprecedented scales. New generations of simulations will incorporate Webb's data, testing whether our cosmological models still hold up an universe that's hundreds of times bigger than our observable patch. And while we may never see beyond our horizon, we can look for indirect signs, subtle imprints in the CMB, gravitational wave backgrounds, from structures beyond our view, and statistical anomalies in the distribution of galaxies that hint at influences from over the edge. If your mind is spinning right now, you're not alone. Smash that like button, subscribe, and tell us in the comments. What do you think lies beyond the edge of our observable universe? More galaxies? Different physics? Or something so alien we don't even have the words yet? Whatever's out there, Webb has made one thing clear. The universe is bigger, stranger, and far more mysterious than we ever dared to imagine. If discoveries like this blow your mind, subscribe now, because with Webb's next revelations, you won't want to be the last to know.